Humans, we're going to be adding and subtracting, unlike fractions. If they are like fractions, it's pretty easy, right? If you have the same denominator, you can just go ahead and do what you need to do in the numerator. 7 plus 1 over a, so it looks like 8 over a is your answer. So the like denominator case is pretty easy, and I think we're happy about that. But what if the denominators are not the same? For example, let's say you're adding these two numbers, d over 6 plus 2d over 9. Well, you need to find the least common denominator between 6 and 9. So least common denominator is synonymous with LCM. So we're trying to find the LCM between 6 and 9. So let's go about that process. Let's write the prime factorization for 6, and let's write the prime factorization for 9. Okay, do they have anything in common? Yes, they do. So write it. And if they have any other factors, remember we're finding the LCM, so we have to represent those as well. Here we have it. Looks like your LCM is 3 times 2 times 3, which is 18. So your LCD for these two fractions is 18. It's easier if you write it vertically to change these fractions to have a common denominator. So let's take a look at that. We have d over 6, and we're adding with it 2d over 9. We just learned that the common denominator is 18. Common denominator is 18. And we're still going to be adding these things. In order to achieve 18, what we had to do is multiply this 9 by 2. So let's do the same thing on top, and you're going to be left with 4d on top here. To achieve this 18, you had to multiply this denominator by 3. So let's multiply the numerator by 3. 3 times d, 3d. So what we're really working with here is 3d plus 4d over 18, which simplifies to 7d over 18. If you're happy and you know it, clap your hands. Nothing changes when you're talking mixed numbers. You still need to find a common denominator, but first, what I recommend is turning each of these into improper fractions before you begin. It's just easier to work with, especially when you start subtracting stuff. Alright, so here we go. Let's change these to improper fractions by way of multiplying the denominator with the whole number part, and then adding the numerator to that product. So 2 times 5 is 10, plus 1 is 11 over 2. And then we have, again, 4 times 1 is 4, plus 1 is 5 over 4. And lastly, 2 times 2 is 4, plus 1 is 5 over 2. And we still need to come up with the least common multiple for all of these fractions. And remember, you can only come up with the least common multiple for 2 things at a time. So let's come up with the least common multiple from 2 and 4. And I hope this is obvious, but here's the prime factorization. You circle what's in common and you write it, and you represent the other stuff as well. So you've got the LCM, or in this case the LCD, is 4, between 2 and 4. Now, talk about this other number too. You've got the LCM from the first two, and let's look at the LCM between 4 and 2, which I think you know again is still 4. So the least common denominator here is 4. When we add all these things up, it looks like we're going to have this, still plus signs in between. And in order to achieve this 4 down here, we have to multiply this denominator by 2. So let's multiply the top by 2. And the new numerator is 22. Over here, we had to multiply by 1. So multiply by 1. So this is unchanged. Same denominator. And lastly, we had to multiply this one by 2. So multiply the numerator by 2. And you've got 10 on top here. So really, the denominator is not changing, but we have 22 plus 5 plus 10. And I think 32, I think 37 over 4 for an answer. Oh, this one looks complicated, but we're just going to add these fractions just like we would any other fractions. You know how to find the LCM, or the least common denominator, between all of these fractions, so let's do it. Let's find the LCM between the first two denominators first. When we do that, we've got 3 times x for the prime factorization, and then 2 times 3 times x times x. So the LCM would be, well, let's see, we have something in common here, so let's write it, and we have something in common here, so let's write it. And you still need to represent the other factors present in the prime factorization. Looks like we've got 6x squared as the LCM between the first two ideas. But let's incorporate this last fraction and find the LCM between 6x squared and 9. Shouldn't surprise you that the prime factorization for 6x squared is 2 times 3 times x, right up there. And then the prime factorization for 9 is 3 times 3. So the LCD for our group of fractions up here, so that we can begin to add them, will be, well, let's see what's in common here is a 3. And I think that's it. But we still need to represent the other factors. 2, a 3, an x, and an x. When you multiply all that together, I believe you get 3 times 2 is 6, times 3 is 18x squared. 18x squared, real small right there. So the least common denominator, 18x squared, we're going to rewrite all of these fractions with a denominator of 18x squared. Don't forget to keep the proper signs in between. And let's figure out what had to happen to 3 to get 18. 3 must have been multiplied by 6 to get 18. But also x, because x times x would result in this x squared down here. So it looks like you have to multiply the top by x squared as well, and when you do, the result will be 24x. Okay? What had to happen to this second equation to achieve 18 down there? I think you have to multiply by 3. When you multiply this idea right here, do you end up with this idea right here? Yes. So you're good. So let's multiply the top by that same number 3, resulting in 15. Sweet. Let's keep going. What needs to happen to 9 to get 18? Well, it needs to be multiplied by 2. But in order to have x squared as well, you need an x squared because there's no x's involved in the first place. If we multiply the denominator by that, we need to multiply the numerator by the same idea, resulting in 8x's that are squared. Whew! Kind of crazy, right? But it's still the same process. So let's keep the same denominator down here, 18x squared, and let's represent everything that's in the numerators with the same signs in between, minus 15 plus 8x squared. Now what? If we had like terms, we would combine them. But right now, there are no like terms. So we're actually done. We can make this prettier by just rearranging these terms by way of descending exponents, so from biggest to littlest. But other than that, 8x squared plus 24x minus 15 over 18x squared. Here is your right answer, your final answer, your most simplified answer. Fun stuff, right?